Okay, so in this problem, we're looking for the internal forces at point C. So as a strategy, I suggest the first thing you do is kind of imagine the structure cut at C, and then mentally think about, well, if I use the left side as my free body diagram, what would I have to do? Well, I got to figure out what this load is, and I have to find what? 2 reactions at my pin. If I do the right-hand side, well, I still have to figure out what this load is, but I only need 1 reaction. So you know what? I think I'm going to work the right-hand side. It seems to be a slight amount of least amount of work. Not much, but a little bit. So that means that, what do I need? I need my reaction at BY. I'm going to go ahead and draw I'm going to assume my reactions at AY are. There would be one in the Y direction, one in the X direction. But I don't really need those. So I'm not going to go for those. So I'm going to do my reactions first. So let me redraw the free body diagram quickly. And I'm going to take this distributed load and make a concentrated equivalent. So what's the concentrated equivalent force of this distributed load? It's base times height, because it's a rectangle. So that's, 18 times 3? What is that, 54? And where does it occur?
9 feet.
Right in the middle, which is 9 feet. So it's going to be 54 kips, 9 feet from A or B, whichever you like. And then, of course, I would have, I assume BY was up, AY was up, AX is to the right. So let's find BY. I could probably get that in one equation by doing what? Summing moments a day. So right-hand rule is my sign convention. I'm going to sum moments at A, set it equal to 0. So about A, with right-hand rule as my sign convention, 54, that 54 kip force creates what kind of moment? Positive or negative? Negative. So it's going to be negative force, 54 kips times 9 feet. And then what's BY? Positive or negative moment about A?
Positive.
Positive. And it's going to have a moment arm of 18. So it looks like BY is going to be positive and equal to 27. Everybody get that?
Correct.
So now I'm going to cut my structure and look at the right-hand side. So I'll draw that over here. That's 12 feet long. I've already found BY. It's 27 kips acting up. Now I need to, I'll sketch it in here, but I need to resolve this distributed load as a concentrated equivalent, right? And what would it be?
36.
Right. It's still 3 kips per foot, but now it's only 12 feet long. So I'm going to have a concentrated equivalent force of 36 kips. And from the cut surface, what's the distance to the load? 6 feet. Okay? So now at this face, I'm going to assume positive axial force, positive shear force, positive bending moment. So as we talked about before, there's one of your first skills, drawing a correct free body diagram that describes the problem. And now what do we do? Yeah, thank you. Let me scratch that out. That's not a K. That's a foot. Thank you. So what should we do first? Some moments where? At B? No, at the cut, right? So I'll assume right-hand rule for my sign convention, and I'll sum moments at the cut. So what kind of moment is this with this sign convention? Positive or negative?
Negative.
Negative. So I have negative the moment. Actually, what I'm going to do is I'm going to go back and, since this is the moment at C, I'm going to subscript all these with a C to let you know this is the bending moment at C. This is the shear force at C. This is the axial force at C. So I'm going to try to get a little better at keeping track of it that way. So there's the moment at C. This 36 kip equivalent force, what kind of moment is it going to create about the cut? Positive or negative? Negative. And the moment is force, 36 kips, times moment arm, 6 feet. And then I have to take care of my reaction force, which is 27 kips. What kind of moment does it create about the cut? Positive. And that'll be 27 times 12. So when I solve for the moment at C, I don't know what you get.
140 kips.
How much?
Oh, wait, I'm sorry.
108. Is it positive or negative? Is it negative? I think it should be positive. Positive 108? Anybody else getting that? Yes? Okay, cool. So 108, and that'll be kip feet. Positive bending moment. So how is the beam going to be shaped there in the middle? Is it going to be smiling or frowning? Positive bending moment should be, and look at this beam with these kind of supports and that load acting down, you would probably expect it to deflect something like that, which is on the order of a smile. Positive. All right, so let's finish this up. I'll sum forces in the y direction. Make sure they're in equilibrium. So I've got my shear force acting up at C, my concentrated equivalent force 36 acting down, and my reaction force By acting up. Looks like the shear force at C is is 9. So I have positive shear force at C. And just to be done, I'll sum forces in the x direction. Make sure it's in equilibrium, and all I have in the x direction is minus the axial force at C, so it has to be 0. Not bad, huh? So any questions about that? Yeah. All right, so we'll stop here.